All right, so let's talk about double angle theory or identity today, um, which is actually very similar to the angle sum. Well, it should be, right? Double angle just means two times an angle, which is the same thing as an angle added to itself. So actually, a lot of these identities are very similar looking, and you can probably get these by yourself, even by just substituting in your sums, except having two copies of the same angle. So we're going to do this like one by one with sine, cosine, tangent, and then we'll kind of jump into some practice and just more review. For the homework, it is going to be Delta Math. So for week one's assignment, it was both the sum as well as the double angle problems. The second one, which is the double angle one, which you haven't technically learned, but it's the same thing. So I hope that wasn't too bad. I hope that you guys get that done relatively soon. So all I'm going to do is, again, I'm going to take a look at what I have, what is given to me here. Given that sine theta is negative 3/5. Now, right now, I don't really care that it's a negative or that it's a 3/5, but rather the fact that it is negative. That's really important. Cosine theta is also, or I'm sorry, it's not also, is greater than 0. So the information given to me so far, if I know that cosine is positive, but sine is negative, that must mean I'm in quadrant 4, right? So a couple things you can do. You can draw your triangle out so that it makes the same. It makes sense in terms of quadrant 4, right? So I have negative 3 over here. I have positive 5 here, which makes this side 4. You can also, right, at this point, you could just say, well, I know it's quadrant 4. I'm going to draw a triangle however I want to draw it, as long as you know what angle you're working with. But because you know it's quadrant 4, you know cosine's going to be positive, sine's going to be negative, tangent's going to be negative. You can do that too, right? Not a huge deal. So with that, I'm going to just go ahead and write down what cosine is, because again, with sine 2 theta, I'm going to need sine theta and cosine theta. Sine theta I have, cosine theta is going to be 4/5. So from here, I'm going to go ahead and say sine of 2 theta. I'm going to first expand this out, which is 2 sine theta cosine theta. Substitute in the values that I have. So 2 times negative 3/5 times 4/5. This is equal to negative 24 over 25. And that's it. Okay, thank you very much. Java update. Appreciate it. Appreciate it. Thank you very much. All right. Now, cosine, very similar. Now, there's three versions here. Normally, you're not going to need all three. I would probably just use the first one. That one has cosine and sine. You're done with it. It's up to you. I don't really mind whichever method you choose to do. But same thing. We have the same triangle here because this is all the same problem. So I still have negative 5 here. I have, I'm sorry, negative 3 there. 4 is here. 5 cosine theta is still going to equal 4/5. All right, so this is, nothing's changed. This is, again, part B of the same problem, just with a different trig function. So I'm going to go ahead and use cosine squared minus sine squared. Now, the nice thing about using cosine squared minus sine squared is that your denominators will already automatically be the same because your radius, right, are both 5. 5 squared is 25. You don't have to worry about finding common denominators. For the other two, 2 cosine squared theta minus 1, 1 minus 2 cosine squared theta, you have to first change your 1 to a common denominator, which obviously is not difficult. But, you know, whatever you like most. Cosine squared is going to be 4/5 squared. Sine is going to be negative 5 3/5 squared. Now, be careful. I don't know how many of you are making this mistake here. I have negative 3/5 as a whole. Like this is one number being squared, meaning that's going to give me positive 9 over 25. Again, I know some people might make this mistake of saying, oh, well, this is, if you put into your calculator, it's negative 3 over 5 squared like that. then it's going to square your 3/5, then give you the negative. You don't want that. You want to have it together. Okay, the negative is going to get squared as well, so it becomes positive. You're going to get 7 over 25 as your final answer. That's it. Now, cosine is a little bit trickier. There's a couple ways to do this. Um, and I would prefer to do one way over the other. But I'm going to show you both initially, and then we're actually going to just do one of them. Still, I'm going to draw my triangle here. Negative 3 rather, positive 4, and 5 here. That means tangent is equal to negative 3/4. All right, so tan of 2 theta, let's do a different color so my side note does not get mixed up with my real notes. That's going to equal to, according to what I have, 2 tan theta all over 1 minus tan squared theta. All right, so what I have here is 2 times negative 3/4 over 1 minus negative 3/4. Now, again, the negative 3/4, because it's being squared as a whole, is going to become a positive. Here, I'm going to have negative 6/4, or I guess I don't need to do that. I can simplify here to get negative 3/2 over 1 minus 9 over 16, which is, of course, negative 3/2 on the top still, over, this is 7 over 16, which is the same thing as negative 3/2 multiplied by 16 over 7. That's 8. When you multiply, negative 24 over 7. So that was a lot of work. I'm going to go ahead and show you an alternate method that I hope will be a lot easier. But in order to do that, I'm going to have to steal my old information here. I do have sine is negative 24 over 25. This is equal to sine of 2 theta. While cosine was 7 over 25. Okay, now the reason I'm taking these is because you know that tan theta tan theta is equal to sine theta over cosine theta. Well, this 2 theta doesn't change anything. Like, all these 2 thetas don't change anything. It's just an angle measurement. So really, tan of 2 theta is the same thing as sine of 2 theta over cosine of 2 theta, which in this case I know is negative 24 over 25 divided by 7 over 25. My 25s are going to cancel out. I get negative 24 over 7, which is exactly what I have here as well, right? So by using what we already know about my tangent, it's a lot easier to find tan of 2 theta and not having to use that formula of 2 tan theta minus 1 over 1 minus tan squared. It's easier, I think. Now, obviously, if the problem doesn't ask you for sine of 2 theta and cosine of 2 theta, then you might just want to do one problem where it's like just 2 tan theta over 1 minus tan squared theta, rather than saying, let me do this and then this just to find tan, right? So it's up to you. Okay. Now, using the correct identity, we want to simplify this. So this is basically going backwards, right? So 2 sine of 5 pi over 8 cosine 5 pi over 8. That is obviously going to be this guy right here. So that's the same thing as sine, I can write here, sine of 2 times 5 pi over 8. I'm going to simplify that, right? So this becomes sine of 5 pi over 4, which of course is negative root 2 over 2. Right, so this is going backwards, not a huge deal, I don't think. Cosine squared minus sine squared, that's what I have right here. So that's the same thing as cosine of 2. The theta here is pi over 12. This is going to cancel as well, leaving me with 6. I should just write down this is going to be 4. Oops. So this is the same thing as cosine of pi over 6. And cosine of pi over 6 is, of course, root 3 over 2. And the last one, 2 cosine squared of some angle minus 1. This is, of course, cosine of 2 theta. Now, what I did see a lot, just on homework and stuff like that, and technically it's fine. People will say, well, cosine of pi over 6, this is root 3 over 2. I can just multiply it. I can just simplify directly from here. And that's not wrong. But the purpose is for you to practice these identities. And not only so, I think you'll find that if you first simplify this by changing it to 2 times the angle, in this case, pi over 6, cosine of pi over 3 is much easier than trying to work out that whole thing. This is just 1/2. Right now, I'm sure if you multiply this out, you're gonna get what? You're gonna get 3 over 4 times 2 minus 1, 6. You'll still get 1/2, but this is right. I'm just substituting it in, and it's easier to solve there. Okay, and I think all the remaining, I believe they're all practice problems that would have been like from your homework. But since our homework this week was Delta Math, I'm going to go ahead and do these so you can get more practice in. All right, so let's take a look. We have given that sine is 5 over. Now, again, I don't really care about the value here right now. I care about the fact that this is positive, and I see that cosine is negative. Right, this means that cosine is negative, meaning that I'm in the second quadrant. Because again, all students take classes, right? Oh gosh, take classes. So therefore, I must be in the second quadrant. My triangle, if you're trying to sketch it out, will look something like this, where you have 5 and 13 this way and negative 12 over here. Because I know, well, because it's the second quadrant, and in order for my cosine to be negative, my adjacent must be negative, right? So cosine 2 theta, I have 2. So actually, you know what? Let me write down what is cosine. Cosine theta is going to be negative 12 over 13. So with that, I think it's going to be pretty simple here. I'm going to have 2 sine theta cosine theta, which I know my 2 values here. I have 5 over 13 multiplied by negative 12 over 13, which is, this is 120 on the top, negative 120 over 169. All right, cosine of 2 theta. I'm going to change colors here just so I can know which ones I'm working on here. Cosine of 2 theta, that's equal to, I'm going to use the top one, the first one. So cosine squared theta minus sine squared theta. That's going to equal to negative 12 over 13, quantity squared. Again, we want that negative inside. Sine squared is 5 over 13 squared. That's going to equal to 144 over 169 minus 25 over 169, which leaves me with 119 over 169. I do reckon. I do reckon. So with last one, tangent of 2 theta. Again, if you want to use the formula, you can. I'm inclined to just say, well, sine of 2 theta over cosine 2 theta is also tan of 2 theta, which I really think makes life a lot easier here, right? If I substitute it in like so, my denominators are going to cancel, and I'm just left with negative 120 over 119, right? I think that's easier. Okay. Let's do one more example here. They tell me tangent is negative. Be careful, this is tangent. Sine is positive. So again, if I take a look at all students take classes, I'm in quadrant 2 again because sine is positive, tangent is negative. Again, my triangle will look something like this. Now, be careful, the negative, I don't I know my algebra 2 kids kind of mess this up sometimes, but the negative in front, it can be either, you can interpret this as -4/3 or 4/-3, but it's really like you need to know which one it is, specifically because we know we're in the second quadrant, right? So what this means is opposite 4, this has to be positive because I'm going upwards, right? While for on my, because I'm it looks like here, right? It's like that. So it's a positive y, negative x. So -3 is over here. 5 is that. Or 5 is my hypotenuse or my radius. So my sine theta is equal to 4/5. Cosine theta is -3/5. Again, with this information already done, it will be a lot easier to figure out my sine of 2 theta, which is 2 times sine theta cosine theta. And that's going to be 2/4, -3/5. It's -24/25. So that one's pretty easy. It's cosine of 2 theta. I got cosine squared theta minus sine squared theta. And that's going to equal to, cosine is -3/5 squared minus 4/5 squared. And that's going to be 9/5 minus 16/5. I'm sorry, 20/5. 20/5. That's -7/25. Last but not least, let's go to tangent of 2 theta. Tangent 2 theta. Again, I'm going to go ahead and use sine of 2 theta over cosine of 2 theta. That's -24/25 over -7/25. 25's cancel. I got -24 over -7, which reduces to +27, 24/7. So these are my 3 values. Now, for those of you that are maybe keeping track of like this, the angle measurements and your sines and stuff like that, you might be saying, okay, why is sine of 2 theta negative when sine of theta is positive? Well, because that just means, well, I'm in the second quadrant, right? So whatever number, whatever angle I'm at in the second quadrant, if I multiply that by 2, I'm either going to be in the third or fourth quadrant, right? That's why it becomes negative. The fact that cosine is also negative tells me that when I multiply my angle by 2, I do end up in the third quadrant. That's why tangent is positive, okay, which makes sense. Okay, so just be careful. Don't let this trip you up, right? Logically, this still makes sense because 2 times my angle measurement is still going to be, it's going to be greater than, I'm going to go beyond the second quadrant, all right? Again, lastly, just going backwards here, right? Using this the sum or difference, I have sine, cosine, cosine, sine, so I know this is a sum of sine. Specifically, the sine also is going to stay the same. So the same thing as sine of pi over 2 plus pi over 6. And they don't ask us to, you know, combine it or anything, just to be able to write it back, I guess, like to get back the same number. So I'm just going to leave it as such. Cosine, cosine, sine, sine. This tells me this is a cosine sum or difference. Now, be careful because in cosine, the sign does not match. So even though this is minus here, this becomes plus 2 pi over 3. And of course, the one with tangent must be tangent. So this one is going to be tangent of, now the sign will match the numerator. So minus 7 pi over 6. And that's it. I hope this video was very helpful, or maybe not very helpful, but helpful nonetheless. Please come in with questions if you have any questions. Thank you.